Alright, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. What I got on the bench today is something I picked up on eBay. I don't know, I got carried away with my purchasing power and ordered something. I thought it would make a good video for the channel, but it arrived. I'm not pleased with what I'm seeing and how it was packed. It's pretty bad when you can tell that this is the bottom of the unit just from the packaging. It's not packaged very well. It's got a puncture hole here, and I can see through the puncture. It looks like it narrowly missed damage. So this is how it came wrapped. Yeah, I'm not overly pleased with this. Let's just cut this box open and get this over with. And yeah, I'm not happy with the purchase that much either. The offer had the seller did have for best offer, so I did give him a best offer, and he accepted it right away, which is okay. That part. But I'm not pleased he waited 10 days to ship it to me before he shipped it, and then it took a 3 or 4 day trip across Canada in a truck in this kind of a box. So what did we buy? Oh my god, this is incredible. Absolutely no padding whatsoever in this box, but it survived. I'm really impressed on how well it survived the trip. And of course, here's the front with no packaging, and everything seems intact and undamaged, which I'm really impressed with. Let's get rid of this box. Okay, so we're not out of the woods yet. So this is that puncture damage on that one corner I was just looking at. And if I look in the box, looks like it took a hit here or here. This is the corner of the amplifier, and that's the front right bottom corner of the amplifier. This corner here is a little better off, but yeah, this is inadequate packaging. I'm gonna have to make sure I mention that in the feedback. So here it is. This is a PM660. It's one of the more high power units. It's pretty beat up. Couldn't really tell how it's conditioned from the photos. There was only one photo, and it just showed the face, and that was it. So I went on a chance that it was still in good condition. Now we do have problems here. We got this corner's bent in, and this corner's bent in from the packaging and the transport, which isn't too bad. I'm really impressed that none of these are smashed, or this glass is not smashed, and everything seems, usually the volume takes the first hit because it's the largest, and it's not bent, and it's not crunchy. Everything looks good. It's just very filthy, and this will clean up nice. I have a feeling this will clean up really nice. And it is heavy. It's a beast. Here's the back panel. These are all undamaged, which is a surprise. Even the grounding post didn't get bent. So yeah, okay. We survived, and we dodged the bullet here. Definitely going to leave some feedback though on this packaging. Alright, screws are out and lid is off. Looks fairly clean, which is a good sign. Got some corrosion around the front here. Looks like a liquid spill along the front panel. That's not a good sign. I don't know if you can see all that. It's all the way across. And we've got lots of Harman Kardon goodness in this one. So we do have a liquid stain here. So this did see some water. It's either it was out in the elements or something got spilled on it. Everything looks intact. It's all original capacitors. Doesn't look like it's been serviced. Fuses are intact. Everything's looking good so far. This arrangement of amplifier reminds me of the HK870. I did a video a while back. It has the power devices mounted on these two large extruded heat sinks, and the same kind of arrangement. It's got all your driver circuitry on a separate board with the drivers on heat sinks. It's actually almost identical. It's got the power supply back here, even with the same metal shield that holds everything. And this looks like Phono stage with remote actuation for these switches, which is nice feature. Yeah, it's a very nice unit. Too bad it's wasn't cared for all that much, but we're gonna fix that up. Something's going on here. What's going on here? I do not know. Have a look. Somebody cut some wires. I don't know what that's all about. That is really strange. And you know what? That's solid core 14 gauge wire that somebody soldered on there. What is going on with that? If I pull the insulation off, you can see it's a solid core 14 gauge wire, like house wiring. That's what you find in your walls. Somebody's been playing around here. Don't know what that's about. This bottom, there's three receptacles. The bottom one has the power cord going directly to it, so that one would be live all the time. The second one up has the red wire, which is your switched from their switch, and then that follows through onto the top outlet. So these top two are switched, the bottom one's live all the time. I really wonder what somebody was doing here. Somebody was tapping power off. Very interesting. And here's another mystery. Aside from the cobwebs here in this, it's been sitting a while. Somebody stuffed this in here. I don't know why. It looks like pencil eraser with some blue stuff on it. What is this blue stuff? What is going on here? Is this a fix for something? And rubber bands? What were they trying to do? That is really weird. I've never seen that kind of repair. Somebody's been in here because some of these screws are really chewed up. Like this one, for example. I don't even see this. You can tell when a screw gets chewed up like that that somebody's been in there with a dull screwdriver. Alright, the big reveal. Light dust on there, not much. What else do we got? Everything looks good here. So far, I just started looking. This thing is heavy. Oh, we've got problems. Yes, let me show you. Okay, here, look at this. We have broken solder joints. This one's broken. That one's broken. That one's close to being broken. This one's broken. This one's broken. This one's broken. All three on this side, and two on this side. This one's cracked as well. This thing suffered some. Yeah, this one's broken. All these solder joints are broken. So there's a good chance some of these transistors, or all of them, are fried. I hope that's not the case. I hope whoever had the sense to stop using this thing when these cracks first started appearing, you get cracks and popples in the speakers, you want to stop using it immediately. Let's check the other channel. The other channel looks to be a lot better. I'm not seeing these ones cracked at all. This one here is cracked? No, maybe not. Yeah, these ones are all okay. It's the other channel that this channel here is all the carnage happened. So I expect, let's just do a quick check with an ohmmeter. Let's just do a quick diode check on this with my meter. Can you see that? Yeah. Okay, where is base? That's a good junction. It's a good junction. Open. Perfect. Good junction. Good junction. Good. Good junction. I think that's okay. I think we're going to be alright. I think we dodged a bullet there. Won't be replacing these output devices. They seem to be okay. Thankfully we got to it in time. So I think we're okay here. I think we dodged a bullet on as far as any damage to the printed circuit boards. I don't see any cracks yet. We'll find out. But I do see other things here, like this solder joint's completely cracked. This is one of the main filter capacitors. And this is our bridge rectifier, filter capacitor. It's cracked here and here. That's not good. Filter capacitor here and here, here and here, and then another bridge rectifier. So we do have lots of cracks going on here on the board. This reminds me a lot of the HK870 I did a few episodes back. If you went and watched that, similar design, similar layout. You have the 8 transistors, and all these were cracking from heat. So what that tells me is this side shows cracking, this side doesn't. This side was probably biased properly, or maybe underbiased, and this side was biased too hot. Too much thermal expansion, too much heat, cracked these joints in no time. Plus it's not a very good layout. And then we have these goofy jumper wires. I like when I did the 870, I eliminated a lot of these wires and beefed up some of these other copper traces just for handling current. Inspecting this tone board here, and I'm finding cracks everywhere on all these potentiometers. There's cracks. There's a switch here. I don't see anything here. Another switch. That one's okay too. But just, yeah, the amount of cracks on these boards is everything has to be gone over and looked at and cleaned and scrutinized and resoldered. That's just the reality of it. So this will be a joy to work on. There's a lot of stuff here that's I like. These burgundy or red caps here, these are Elna caps. These are for audio. These are some of the best caps ever made, to tell you the truth. Elna makes great caps during this era, but these ones here are always a step above. They have super thick leads, very low ESR, and they're jumbo size. These are 10 microfarad caps, and they are probably double the size what they need to be, just because they have more internal stuffing. And Elna went all out on these caps. They're probably test fine too if I test them. But as far as the other caps on this thing, they're all Elnas, and there's also some Mashishita caps. These blue ones will be garbage. They'll be done, and then there's also the green TK ones will be garbage. And these Elnas hold up really well, but they're all going to get replaced and refurbished. Don't know if these are broken. These two tape monitor switches, they're not latching. Oh, they are latching. You can hear it latching, but you can't tell by the physical button. Okay, and then this is your function switch. Okay, nice feature on this PM660 is these function lamps. are all replaceable. You just give them a quarter twist with a screwdriver, and the bulb should just pop right out, just like that. And these will be intact. You can replace these. They're riveted. The leads are folded over and riveted to a brass rivet, but you could cut that wire and just solder to the rivet. The rivet makes contact on this side with the copper pad, so you don't want to solder on this side, and you don't want solder flowing through. You want to tack it on the back side. But that's how that works. And I expect all these lamps should be working. I won't have to replace them. So part of me wants to power this thing up and test it at its current condition. But I first have to go on and resolder all those transistors and those filter capacitors that are cracked. But then that leaves the probability of cracks on the driver board, which I can see from looking down here. I can see there is cracks. So I don't dare power this thing up with all those cracked joints, because it could just be catastrophic. I'm sure probably somebody's plugged it in. The seller might have plugged it in and tested it, but I don't know. But I'm not going to risk blowing something just from that. So I'm going to wait till this card comes out, and it has to be reworked, because there is a lot of stuff on here, and I can see just from up here I can see cracks. There's connectors on the bottom that are cracked. Where else? Probably a few of the transistors are cracked too because of the heat. So we'll just leave that for now. We won't power this thing up until after we've done all our work. So what did I buy here? Well, this is the PM660. This is quite a desirable amplifier from Harman Kardon. It's got all the business inside, like you saw already, to do the spill the beans. It's very well laid out, and it's very nicely optioned amplifier. High current capability integrated amp. Got a chunk power button here on top, 2 speaker switches, and headphone output, which is pretty standard affair. Now it has this bar here that you can't see anything, but it's actually lamps, and behind here one says on and one says wait. So that's your power on wait, and then once it goes through the power on cycle, it switches to on. You have a tone defeat button, and your bass treble controls, your balance, and a mode switch, which is nice to have. Mono, stereo, or reverse stereo. Okay, excuse the filth, it's pretty dirty. A subsonic filter for your vinyl players, and a high cut for your FM stereo listeners. And we have a tape out selector, so we can select our source for our tape tuner, source off. So we can actually put it on source, and then we can select with these 3 buttons, or we can go to tuner and listen to something else on auxiliary or phono. I think that's how that works. Turn it off, so no output on the output on the tape output, and then we can do our dubbing 1 to 2 and 2 to 1. Okay. Main direct -7 dB. I'm really not too sure about this. I think it bypasses all of the tone circuits and gives it a bit of attenuation too. So you can use this kind of like as a power amplifier. I have to read up on that because I'm not entirely sure. -20 dB audio mute, loudness, and then we have 2 tape monitors, 1 and 2, and everything is backed up with a light. So here's a light for tape 1. You can't see it. Tape 2, auxiliary. So on this end we have our 2 tape monitors and our 3 function switches: phono, tuner, auxiliary. All these will need to be cleaned. Our main volume control, and we have a cap trim. So this adjusts. This is a switch, I believe. Yeah, very stiff switch. We can adjust our load capacitance according to our cartridge, and then we have a switch here to select between phono 1 and phono 2, because it does have 2 phono inputs. And then we have our moving coil and moving magnet selector for the phono stage. Very nicely optioned out, and like I said, this thing's ready to do the business. It's got the power too. I'm not sure 80 or 100 watts a channel, maybe 90, I'm not sure. I should have done some more research before I turned the camera on, but you can see how dirty and filthy it is. It's going to clean up nice. And hopefully these scuffs will come out. This is on the aluminum faceplate, so hopefully this will clean up really well. We've got damaged corner here, damaged corner here, which I can straighten those out too. Started tying into this. First thing I do is remove the rectifiers, filter caps, because you have to get in here. These caps are testing fine. They are 10,000 microfarad at 63 volts. And this is what they measure. And you can see it up there. Coming back at about 94, 93, 100 microfarads. I think these caps are just fine. I'm going to leave them in there and keep running with them. Part of the reason why you need to get this all disassembled is to get this shield out. It really doesn't do anything. It's, I don't know what it's for, but you could probably run without it. But you can see there's glue corrosion here. Let me show you. I hope you can see this. Here's a little bit of light maybe. Can you see the corrosion on those two diodes? Yeah, that's the reason why you got to take the shield off, because you'll always find this with the corrosive glue. More surprises. I'm disassembling the amplifier. I'm taking out the heat sinks, remove the transistors. This is all going to get disassembled for cleaning, and I'm finding some interesting things. The heatsink assembly came out, and there was this metal plate. I don't know if anybody recognizes that, but that metal plate was stuffed down inside here. I have a feeling it was to keep the broken connections. I think it was they were trying to make a connection. Same with the electrolytic capacitors, had something stuffed behind them, and I think that was just to give it a little bit of a push to make that connection on that cracked solder. So yeah, this is weird, but we got it out now. We can clean this up and get it ready for reinstall. Now I got room to work here. This is all open now. Now that all of the heat sinks out of the way, we can get in here and start to see. These are the interboard connector right here, and this is all cracked. A lot of these joints are cracked on that side, and on the other side as well. I can see quite a few of these are cracked. So this is the problem with this using this amplifier. You just can't turn it on and expect it to work. It'll probably grenade itself. Here's a bit what I was talking about with these Elna caps, these burgundy caps. They have written on them for audio. Where is it? Right there. 16 volts, 100 microfarad. Look at how big this thing is. For comparison, here's a modern 1600 microfarad. And you can see the size difference, right? And there's a reason for that. Look at the lead size difference. The lead sizes are huge compared to the modern equivalent. Very thick leads, wide body, and I'll measure this one here. This is 100 microfarad, so let's measure this. You can see we got 99 microfarad, and it's about 700 milliohms. All right, let's look at this Chinese one. Here's the Chinese one, 116, 1.3 ohms. So the ESR on these Elnas is actually half of this one here. This is a brand new. How do you pronounce that? Kinsha is an SHG brand. This capacitor is rated at 10,000 hours at 105 degrees Celsius. So it's a very, very well built, high quality capacitor, but it doesn't even stand up to these old Elnas. So these are going to go back in. They're testing perfect. So I'll put those back in the circuit. All right, we're off to a good start. This is the Phono board done. I didn't replace all the caps. All of these Elna caps I left in. I pulled them out and tested them. They were all 100% fine. So I left them alone. I did replace the TK caps, and I did replace the Mashashita caps. So we got in power supply, we got solid polymers, and then we have audio grade here. All the rest of them are audio grade. clean the switches. I pulled this one out and tested it. It was actually pretty good. It was less than 60 milliohms, and then I gave it a clean with 401B, this stuff here, and it actually dropped down to about 20 to 15 milliohms. Back of the board's clean, and everything's been resoldered, and this board is ready to go back in. Now I'm going to turn my attention to the driver board. Got lots of work to do on this one, I think. Actually, there's very few caps on this board, and they might all just stay too. These are all Elnas. But again, we can see these resolder job here. Come on, focus. I don't know if you can see how cracked up they are. And then on this side, it's the same thing. So I'll start on this and we'll get this cleaned up. Part of what I do is I take all the transistors off and repaste them. This is another thing that takes all the time, is making sure that they're all got probably proper paste on them. Alright, finished with the driver board all back together and ready to go back in. Now I did have some problems here. Well, aside, did a lot of resoldering. These connectors were all cracked, so I resoldered them. When I lifted these capacitors, they were stuck down with a conductive glue, and they were starting to corrode underneath the traces. I don't know if you can see that. Traces are, well, the solder mask is damaged. But I'm going to tack these back down with some neutral cure silicon, and I got rid of all the conductive glue, cleaned that all out. I'm reusing these capacitors because they're probably better condition than what I could replace them with. And all these capacitors are only power supply bypass filtering. So these are for the positive and negative rails, 100 volt capacitors. And then they had these 4 capacitors here. Same thing. They have a little regulated supply with a Zener, 1 for each channel, or 2 for each channel, positive and negative. And these are the filtering caps for it. So I replaced these with solid polymers. They have really low ESR, and they'll do well on this job. Now I did have problems putting this back together. I was putting the heatsink back on and repasting the transistors. I was getting shorts on some of these TO220 transistors, and I couldn't figure it out. The factory used a really thin and kind of wimpy insulating shoulder washer for these, and they used it on one side only. So what I did is I had problems getting them to bolt down without a short. So what I did is I just added another shoulder washer insulator on the back side of the aluminum heatsink, and that helps. What it does is it helps center the screw in the hole, and it won't allow the screw to be off center and touching on either the heatsink or the transistor, which I think the problem was. So once you put the insulating washers in, it centers and that short goes away. So these are all good now, and this thing's ready to go back in. Not much else to talk about. Okay, starting to assemble and I'm putting things back together, but I'm not turning the camera on very much. So I did have this front plate off, and that exposed the tone board, and I did not recap the tone board. I only recapped a select few capacitors. All of the capacitors that were Elna for audios, I'm pulling out, testing them. They're all 100% fine, so I'm putting them back in and I'm running with them again. I see no advantage to changing those caps out because they're probably better condition than what I can buy brand new today. Switches are another thing. I took all these switches, opened them up, all of these little switches, and this one here too. And I used neutral 401B on them. This seems to be the best stuff, the best magic formula for switches. Now, I could replace them, but I don't know if there's going to be a need. I took a bunch of them out and tested them on my machine here, and they're testing all below 50 milliohms of contact resistance, which is really good for an old switch like this. So that's why I just decided just to treat with this stuff, work the switch, and put it all back together. And actually, after I did the treatment with the 401B, the contact resistance dropped to like 20 or 30 milliohms down from where it was. So I'm confident the switches will be okay, but I don't know yet. I've never powered this up before, so I don't know if any of these pots or switches are going to be problematic. Might have to come back and do another treatment or a fix. Resoldered a lot of the tone board. This suffers. You know, I gotta say, this amp hasn't seen much use. It's a very low hours amp, so not very many cooked components. Crack solders are not that prevalent as well. Now, I put the heatsink block back in. You got to be very careful with this. These are like razor blades, and when you take it out as a unit, what I did is I removed all the transistors and then take it out as a unit so I can clean it and get access to the board underneath. I found a problem here with the manufacturer. They used a thread locker, and what that thread locker did is it wicked out from underneath the screw and it went under the transistor, and it kind of glued the mica washers down. And when I removed the mica washers, I had this mess under here, pretty much on every screw, and I had to take a Dremel with a little wire wheel and clean off all that residue of that adhesive, because otherwise this wouldn't be flat. So I got those all cleaned off. That's ready to put the transistors back in. I'm going to address these wires. I don't like this arrangement they have. They couldn't get enough room on here for another trace, so they put this wire. This is a bodge from the manufacturer. I've addressed this on the HK870 video. I think I remember I went through it, and I went and removed these wires and put alternate wires in so that they weren't hanging like that. Other things I've done is I removed, get this out of the way, isolated grounds for left and right. Okay, that's great. And they went back here and then back up here to these ground posts. So I cut that wire out, and I took the wire from here and I moved it directly to ground zero of the power supplies capacitor bank. So here's our left and right grounds connected now. It's a lot shorter path, more direct. Phono board is in, and you can't see it. Phono board is back in. Again, same thing. I replaced the select few caps. Left to do, I gotta stuff the driver board back in, and that driver board's completed. I just have to plug that back in, 2 screws, and connect one plug, and that's connected. And then I need to do the transistor work, repaste the transistors with fresh compound and torque them all down and resolder this board and fix up these wires. I also noticed that on this amplifier, the original factory heatsink compound was still in good condition. So that tells me again that this was a low hours unit. Didn't see a lot of high hours of baking and cooking everything. So that's good. I can get this assembled and put back in, and I can fire it up for the first time after I put the caps in, of course. The little metal shield here was made out of some tin-plated steel. I'm pretty sure it's tin-plated steel. And it's prone to rusting, so I just pulled it out and hit it with some flat black spray paint and just cleaned that up so it prevents it from rusting and gives it that sinister look. Okay, wherever they had wires, they had these wires glued down to the printed circuit board. Wherever they had the wire glued down, they had a blob of glue, which is corrosive and conductive. So I've had to remove all that, and I've been scraping away at this board, and there's a lot of damage to this board now. I can show you a few areas where it's been damaged. So for the most part, I cleaned it up with the soldering iron, like this area and this area. But you can see this on this. Let me zoom in. Look at this trace here, has got corrosion on it, and it's under the solder mask over the copper. So what you can do is you can scrape off the solder mask, scrape on the corrosion, and we can bridge that with a blob of solder just to cover it and protect it. If you leave it, it's going to continue to corrode. Eventually it'll corrode through, so let's just put a little blob of flux And let's try to get this looking decent. Doesn't want to stick. The corrosion is there and it's keeping the solder from sticking. But eventually the flux will remove enough corrosion. Okay, I think I got it there. I don't know if you can see that too well. Actually, you know what? It's being very stubborn. There. And if you want, you can cover that with some solder mask, some UV cure solder mask. Clean this up. And I got a few other spots here. One spot here is really bad. You can see it. This is a connector for from the collector. It goes back to the circuit. So this trace here is quite corroded, even though it doesn't really look like it, but when you scrape the solder mask off, and this can, you can get a trace open up from this corrosion. That's what we're trying to prevent. So I'm going to work on this and get this cleaned up. And then we can get our transistor solder back in. But you can see these spots here. Here's a spot here, wherever they use the conductive glue. And then there's a spot here, right in the center. There's a spot here that's bad, and it's right over a transistor. And there's a trace there that needs to be repaired. So this is what you got to look for and deal with. Been scraping this one back. I don't know if you can see this, but this trace is just about completely eaten through. There's a spot right here where there's a big chunk of copper missing. So I think I might have to just lay a wire on here and reinforce that, because I don't want that to break. Even spreading solder over top of it, it's not going to fix it enough, because it could still corrode from the sides and underneath. So I think I'll just lay a wire across there and fix that. Going through and repasting transistors, getting them installed. So what I do is I smear paste, stick down the micro washer, get it prepared, and then the transistor I paste separately, and then just drop it into place. Now I'm using blue thread locker on these. I know some people might think this is necessary. It probably is. You don't want these screws backing off and loosening off and losing that thermal connection. So I'm just putting a bit of blue thread locker on each one. And then I don't tighten them down yet. I just start the screw and leave it loose. And I'll come through and I'll retorque them all at the same time. And just keep plugging away. Now that all the transistors are placed, I'll go through and I'll tighten them all down. And I do it in steps. The blue thread locker is already working its magic. I can feel it. So I got to get this done quickly. Now I don't know how much torque you put on an M3 screw, but it's not very many. It's probably, I don't know, I'm going to guess here, maybe about 10 inch-pounds. You don't want to go crazy with this because it is just an M3 thread into aluminum, and you don't want to crush the transistor down. You just want it nice and snug. So I'll go through. And you start to see the compound squish out from the mica washer and the transistor. Okay, so I'll go through and snug them down. But like I said, don't go crazy. And then give it 5 minutes to sit, and then come and try it again, because that heatsink compound is very viscous and it wants to flow, and it'll flow out from under the transistor, and then it kind of, the pressure will relax as that happens. Okay, so what I'll do is I'll solder these down. We can even do one right now if I get the right solder. Let's start here. See, I don't like this. They should be down. Flood it and make it a nice shiny joint like that. A nice shiny joint. It's easy to inspect now and in the future. If anybody comes in here and wants to look at this, they can see right away if there's any cracked joints, and then could touch them up. Alright, so I'll do soldering and then I'll retorque them one more time. And one last thing you always do is you check for continuity between your heatsink and your collector, just to make sure there's no shorts. So there's our, okay, so we go through and test every collector. Everything's good. No shorts. That's what you want. And if you do have a short, correct it. Otherwise, if you power it up, you're going to blow up your amp, because you'll have a direct short from collector to ground, which is VCC or V minus CC, whatever, to ground, and it'll blow up your fuses or power supply or whatever. Alright, now the transistors are in, I can add some bypassing around the output devices. So what my plan is to put 4 1 microfarad caps from collector to collector, and there's plenty of room for it, so that's what it'll look like when it's done. And we have a nice flat spot here we can use as our area for the, so let's just place down some neutral cure silicon. That should be good. And you can get this in place and solder it down. I already preformed the wires to conform with the pads. So let's solder this side down. Tin the lead. side's done. Just going to bend this back a little. Maybe I'll trim it. That's what I'll do. Trim it. I got it a little bit too long, about 1 millimeter too long. There. Do this side. Okay, so squeeze down the silicon. And that capacitor is there. Now, the collector on this transistor are directly tied together. And same with the PNP side. This collector and this collector are tied together. So I'm using 2 capacitors. So actually what I'm doing is just doubling them up. Instead of 1 microfarad, it's going to be 2 microfarad and half the ESR. These are 400 volt caps. I could probably get away with 200 volt. They don't need to be 400 volt. But just for, this is what I got in stock right now. So that's what I'm using. You can do another one. This neutral cure silicone is not okay. Alright, so I'll get the other ones in and then I'll be done. So here's a look at the display board. I'm just getting some loose ends tied up before I close this up. So they have this display board. These are incandescent lamps in these positions. And they're using this arrangement of these Zener diodes. These 6 diodes here are Zeners. And they're arranged in 2 strings of 3. They have a 4.7 volt Zener and then 2 3.6 volt Zeners wired in series to provide a 12 volt Zener action out of these 3 diodes. Now I think they do this for the lamp circuits just so that when they switch in and out different lamps, the brightness doesn't change. It kind of regulates the current through the lamps. They could do the same with resistors, but they would never get the effect of constant brightness if they had lamps switching in and out on the circuit, which is why I think they do this. So it's kind of burnt up here. You can see it's quite a bit of heat. So these 3 diodes here are taking all the current, it seems, because they're the ones heating. These 3 diodes here are just have life on easy street. So I lifted the leg of one of each string, and just to test these diodes, they're all fine. I'm not going to change them out. It's not a critical application. It's just for lighting. So probably what I'm going to do is remount these diodes so that they're off the board maybe a millimeter or so. I think there's enough lead. There's enough lead, excess lead stuff on the back here. I can raise the diode. I'll just lift it up a little and resolder them down. And I'll just leave that alone because there's really no need for me to do anything here. Alright, I think we're all back together and ready to do our first initial power up. Did a lot of work in the background without anybody seeing it because this wasn't filmed. We had to replace 3 lamps that were burned out, and other than that, I tested these 4 fuses. They're all fine, so I put them back in. The main power fuse is 6.5 amp on the AC side, the main side. You can see the glue is still intact. It hasn't been touched since it was done in the factory. Or maybe I'm a liar. Let's take this off and have a look. Maybe it has been off, but it's really difficult to get these off. Let me see. The wires are in the way, that's the problem. There we go. So that's original 6.3 amp fuse. It is intact and it's the correct value, 6 1/4 amp. Put that back. We don't need to do anything with that. So let's plug it in and power it up and see if it's flies or fries. Okay, it's open. Here we go. Jumped up to 120 watts, dropped down to 35. It's hovering around. Oh, there we go. Jumped up to 60 watts. So the amplifiers came online. So I'll need to set the bias up. Staying around 65 watts. That's not bad. So I'll have to set up the bias and the DC offset. We can check DC offset right now. Can you read that? I believe so. So here is the right channel. 2 millivolts. No, we got 123 millivolts. Left channel. We got 23 millivolts. It's dropping on the right channel is dropping. So that's good. Watts and slowly climbing. I wonder, the only thing I don't like about these amplifiers is it's so difficult to adjust the monitor the DC bias and check it here without shorting anything. We've got 90 millivolts on that channel, it's way too high. This channel, can't get a reading on. It says 0. That can't be right. 90 millivolts on that one. 0. So I might have a problem on this channel, I don't know. And we got too much bias on that one. I have to see what the spec is. Now it's 70 watts and climbing. So it might be okay. Let me get set up and do a bias adjustment. Definitely have a problem on, I think it's the right channel. There's no bias adjustment whatsoever. It's sitting at near 0, and if I turn the pot, makes no difference and no adjustment. So we got a problem. Somewhere on this driver board there's a problem. This side was at 90 millivolts and I adjusted it down to 50. The spec is 50 across both emitter resistors, so that adjusts out just fine, but this one here has got a problem. So the first thing to check is these 2 stabilizers. There's one on this side and one on this side, and they sense the heat sink temperature. They're stacked diodes. So let's check and see if we have continuity on our stabilizers. Let's see if I can get this in frame. And the 2 wires come down here to these 2. Okay, so I got open circuit there. And I got 2 diode drops there. Okay. Open circuit there. 2 diode drops, but it's not the same. It's not the same as this one. I wonder maybe if, oh, that changed. Why is, or am I measuring the wrong spot here? That's why. So we got 1.11 there, 1075 there. So I don't think those are the problem. Okay, let's see if we can figure out what's going on here. Here's our schematic for the right channel, and our right channel's on this side. I believe it sits like that, so yeah, makes sense, right channel. So let's check around here. I see there's a couple of fusible resistors. For example, there's 2 on this side, 2 on this side. So that's usually what you go for first, is to check fusible resistors, make sure that they're intact, and we can do that right now. So, oh, here's my meter. Okay, so this is our, here's 490, R490, and we have, oh, I'm on voltage. Sorry, wrong scale. And we have mega ohms. This is supposed to be a 2.2, so that one's shot. This is 490. Where's 490 on this? See, why did they have three? I guess they're on different boards. The parts that are numbered 300, 400 are these parts. So, oh, here's 490. So this one's shot. Okay, let's try the other one. There is one 496. Where's 496? 496 hidden underneath this cap. You can see it right here. Let's try this one. It's supposed to be 56 ohms. 56 ohms, that's correct. And then our 494 is, it says 22 here. Our 494 is right here, and it's another 2.2. Let's measure this one. We've got mega ohms. So that one's shot as well. This one's shot, that one's shot. We're starting to see a pattern here. So I wonder what the condition of these two transistors are in. If these two fusible links are open. I'm assuming everything here is okay. We have no bias adjustment. This is all our biasing circuit here in between these. Let me try Q434, 436. Q434 is the green one in the corner there. And that is a driver transistor, so we can diode check. Emitter collector base. So, emitter collector base. Base is on the right. Emitter. It's open that way. Diode drop that way. Ah, direct short. Direct short between base and collector. So this is 434. This transistor shot. Base to collector. Which means this one might be damaged as well. 430. Where's 430? Q430 is right next to it. Emitter collector base. It's a good junction there, but I got no junction here. It's open. Good junction there. Not a good junction there. Something's weird with this transistor. Or hang on, no, I got it mounted backwards, that's right. So the base is on this side, sorry. Okay, so I should have a junction. I do. Junction, and I do. No collector to emitter short. So that transistor's fine. This one's fine. Q436 is this one here. 2SC2238. Emitter collector base. Okay, that's weird. Okay, so I should have a good junction here, and we got something wrong there. That's base to emitter. So base to emitter, we have, well, we might be reading 100. This is open. Emitter is open, so there should be no way for this to have a reading. That transistor's bad. Okay, let's check 432. 432 is this one here. It is facing that way. Emitter collector base. Good junction. Good junction. No shorts. Good. So it looks like we have 4 bad parts here. I'll have to see if I have these driver transistors in stock. It's an A968 and a 2SC2238. I probably don't have them. I'm going to have to substitute something. And then I need a couple of 2.2 ohm fusible resistors. And that should put us back. It's odd that it blew up that way. I should check 306 as well. So I'll have to check this one. R9. Which one is it? 306. Check that one. I want to check 498. It's 15 ohms. 498. Oh, here's some 3 series parts. 308, 302, 304. What am I looking for? 306. 306 is right here. We got 82K. I don't think that's right. 82K on R306. So this one's shot. 498. R498, where are you? 492, 494, 490, 488, 488, 488, it's 100 ohms. Let's check 488. Mega ohms, that's open. Wow. So this one's shot as well. Still need to find 498. Yeah, 498 is right under here. And it's supposed to be 15 ohms. Let's check this. What's going on here? 15. Okay, that's good. .310 is shunted with this coil, so I doubt that would be open. Same with 312, shunted with a coil. 492. This one was shot, so maybe 492. R492, where is it? R492 is right here. Mega ohms. 492 is shot. And we tested Q430, 432, they're fine. So it's just all these resistors and these one transistor. Both transistors, 5 resistors. Yeah, so let me get checking these. I think that would be it. Like we could check farther back in the circuit. I could check 426, 428, and 450. I don't know where 450 is. I can't find it on here. 450. 412. I don't see a 450 anywhere on here. Unless it would be on the other board. I'll have to look. I'm going to pull these parts out and start replacing them. I'm going to see if I have subs or originals. If I don't have originals, I'm going to have to find a sub. Alright, so I replaced 4 resistors. 2 here, 2 here. And I checked this R306. I measured it open, but now I'm measuring it fine. So here's R306. Where is it again? Right here, down here. And it measures 15 ohms. And this is the other one, R498 is 15 ohms. Okay, so those two resistors are fine. This one and this one. And I checked these two transistors, they're fine. I'm looking for Q450, and I can't find Q450 on here. And then I realized there's a mistake on the silk screening. If I look on this one, this is Q449. So this should be 450 here, but it's not. It's marked Q428. And you can see that, 428 there. But then if you look down here, there's another Q428. So they got Q428 marked twice on this board. And so this one's 450. I should actually mark that Q450 if I get a pen. And just put Q450. Make it less confusing for the next guy if there is ever a next guy. So got these two transistors out. Where's the other one? I lost it already. Here it is. Let's test these. This one here is the 2SC. So let's try this one. Bingo, bango, bongo, it's no good. Okay, this one here. This is the A. Time to replace the socket on this thing. It's getting pretty beat up. Come on, get in there. Alright, try that. Direct shorts. Okay, so those two are shot. But I did find, I have some in my stock, some used pulls. And we'll get these two out and get them tested and installed. Transistors are installed. Let me have to do a quick continuity check on the collector tabs, make sure there's no shorts. Everything's good. Okay, so this is all I replaced, these two transistors, these four resistors. And I did check these two, they're fine. I checked these three, they're fine. I checked these two resistors, these 82 ohms, they're intact. So everything's good. So I'm going to put this module back in. These are our output devices, these four. I doubt they got damaged because this is all open circuit here. There's no voltage going to these transistors. These fuses burnt because one or both these transistors shorted. So there should be no damage to the output devices themselves. They should be saved. Powered it up, nothing really happened. We had no current flow through the transistors because nothing was turned on. These were essentially removed from circuit with these four resistors open. So we should be good to put this module back in, but I'll check these just as a precaution. And I happen to think this all blew up because of these cracked solders on these pin connectors here and here. They were all, a lot of these were all cracked on both channels, and I think that might have grenaded this. It's hard to say. I have to glue down this cap again because I was soldering directly underneath it. I'll clean this board up and then I'll re-silicone this. Okay, we're back together, ready to do another power on test. So let's turn this thing on. And there they go. So it looks like we're okay. Nothing weird, no smoke, no outrageous power consumption. So let's check for bias on both sets of emitter resistors right now. Let's see what we got here. can't see that, but it's in my way. So let's. I have to be careful with my hands around here because this is mains voltage on these pins. I don't want to lay my hand on it. So what do we got here? 44 millivolts, and I remember setting it. What do we got here? Come on. 37? Can't get a good. I don't know. I can't do that with these probes. I have to measure it from underneath. I think it's working. That's the main thing. Let me shut this off. Okay, it is working because I have adjustable bias. Amplifiers are turned on. Everything's 100%. So I can turn this up to 50. I'll leave it a little low because it's going to warm up and it's going to consume some power and heat up. Look at, we're doing 70 watts here. So I'm going to let this stabilize for about 20 minutes. Make sure that these are at the correct value. I'll do the DC offset again, and then we are fixed. Result. So all the face plates of these Harman Kardons are pretty much stuck together with double-sided sticky tape. You can see on here. And double-sided sticky tapes holds all these buttons on, and then they double-side sticky tape the window in, but they also run a bead of glue along it. Same with the sides. The sides usually fall off because the sticky tape lets go, and the glue, I think it's the same glue they use in circuit boards, and after 45 years it turns to crust. So what I do is I typically epoxy these back on, but you got to clean them first, and I use tetrachloroethylene, and this stuff should remove any of the adhesives. Yeah, it just cleans it right off. Right down to bare metal. I wouldn't get too carried away cleaning, but I'm just trying to make a good surface for the epoxy to bond to. Because you got to take, first you got to take a knife and scrape away the double-sided sticky tape, and then you got to clean off the adhesive. So this is working great. This side. And then we'll mix up a batch of 2-part epoxy, and you got to be careful you don't put too much on because you don't want it flowing out to the front and making a mess and having it visible. Even if these are just hanging on by a thread, better just bust them off and re-glue them because they're going to eventually come apart. This side, I need a little bit more juice. There we go. Alright. Same with this, clean this. This stuff will eat this kind of plastic, so better to think of maybe some alcohol, maybe it would take that off. Alright, let's get this thing power tested because I got stuff stacked up waiting for the bench, and I just want to get this out of the way. Spent a lot of time on this one. It sat here for, well, more than a week getting work done, and I think it's time to move it on. And okay, so let's turn this on. Let's do our power test. And plugging it in would be a good start, Trevor. Yeah, that would be a good start. Plug it in first and then turn it on. And we should have our signal up on the screen already. Feeding it. Oh, we got to select auxiliary. Okay. I think we're there. Let's see, do we have any signal? Yeah, we do. Okay, so let's increase this. We got both channels driven. Alright, turn this down. Okay. Here's clipping. back this off a little bit. Set it right there. Right there, we got 28.81 volts RMS on the output. Let's start our timer. And let's do our 10-minute wait. Here's 300 and almost 350 watts going in. Coming up to the 10-minute mark here, and this thing's barely breaking a sweat. What do we got here on the main heat sinks? We got 52 degrees, 53, 51. This side's a little cooler, 49, 51. Yeah, this thing is not. This thing's built to do the business. This, on the other hand, is well over 100. Wow, 180, 190 degrees Celsius. So we're smoking my load, but this thing is working fantastic. I bet you I could put this on for 20 minutes and it would make no difference to this thing. This is amplifiers like this, where they have the tandem outputs and the really low output impedance on the amplifiers. These are good for driving 4 ohm loads, and this thing would go all day. Yeah, 55 degrees max, and we're at 10 minutes of baking it. And I noticed the power consumption dropped from 350 down to 340, and slowly came down as it warmed up. So that's a good thing too. It's not going to grenade itself from heat. So we'll shut this down, and let's see here. Shut this down, and let's go for our square wave tests. Okay. Bring it down to 1 watt. That's 1 watt there. Okay, so we got 1 watt or thereabouts at 1000 hertz. Now I'm more interested in these controls. There's a speaker switch. I don't know how badly these controls are. So there's bass cut, bass boost, treble cut, treble boost, balance. Ooh, balance is scratchy still. Okay, well, when you work it, it gets better. Here's our balance. Tone defeat. Right channel increases in gain a little bit, but then we lose our tone controls. Alright, this is our subsonic. Really no effect. High filter. Kills the highs. This is our main direct -7 dB input, so it drops the attenuates it, and this is our mute. That drops it quite a bit. Loudness, typical loudness control. Tape monitor 1, switch is working good. Tape monitor 2. Switches look clean. I'm pleased with that. Okay, so this is tuner, phono, everything looks good. Let's see what this thing can do as far as on the low end. Let's go down in frequency, 100 hertz. 100 hertz, 90, 80, 70, 60, 50, 40, 30, 20, 10. 10 hertz. 1 hertz. I don't think I've ever seen an amplifier go down to 1 hertz and look like that. It's pretty good. I'm impressed. Alright, let's go back up. Okay, 1000 hertz. Let's go up in frequency. 7, 8, 9, 10. Kind of looks all... I don't know if that's the scope or I'm just picking up noise. 15 kilohertz, 20 kilohertz. Let's go up until we lose our... Probably right about here somewhere. 77 kilohertz. It's doing pretty good. Very happy with this amp. Can't wait to wrap my ears around it. Yeah. Alright, here's a look at the parts that went into this. So this is all the caps I put into it, surprisingly enough. These 4 alone are actually fine. These are these Alna for audio caps. But I decided to replace these 4 only because they were in a power supply circuit and I could get a better result with a solid polymer, so I replaced those 4. These TK caps and these Masashita caps are all garbage. They measure down in microfarads. This one's a 220, for example. And if I measure it now, it's going to tell me something that's not anywhere as close to 220. Let me see here. Try this out. Yeah, we're reading 199 microfarads, and ESR is up about half an ohm. It's not the greatest. But these TK caps are you got to get them out. They're not very good. Even though in the 80s, I got to say, in the 80s, these caps have improved. But still, that's the caps end of things. Replaced 3 lamps. These 2 diodes were destroyed by conductive glue corrosion, so I replaced one of them as a Zener, one's just a regular silicon diode, so I replaced them both. And this is the damage that was on the driver board. We had 4 blown resistors and 2 blown transistors. So that's it. Well, there it is. I'm done. It's not the best cosmetic condition I've ever seen. Like, it is kind of beat up, and it does have a lot of battle scars all the way around. It's had a hard life, but I could tell that the previous owner tried taking care of it. The solder cracks inside, he tried to do something with it, stuffing objects in there to get it to work again. And somebody really loved this amplifier, but it just got too bad, and one channel died on it, and then I think they gave up on it. It was an eBay find, and I did buy it to flip, but I know just in my heart right now that I'm going to have a hard time detaching myself from this once I hear it. I have a real problem letting go of equipment that sounds good, and I know I have to clean house here, but once I hear this, I think I'm going to want to keep it. So we'll see. I'm going to, after shut the camera off, I'm going to connect it up and start listening to it. I have lots of other HK stuff coming up. I might as well rename the channel the HK channel, because I have 3 more receivers waiting for the bench. One of them is a restoration, one of them is a quick repair, and one of them is another AVR diagnosing video. So stay tuned, there's lots coming up, and I have lots of other stuff other than HK too. I'm just trying to get some of this stuff out of the way, and I'm trying to get things cleared up and some things sold so that I can make space. I can hardly move around here. So thanks for watching, take care, and we'll see you on the next one.